last thing we're going to discuss is solving inequalities algebraically. Here I have y is less than x squared minus 8x plus 15. Well, I can factor this. I can make this say y is less than x minus 3 times x minus 5. Now if you think about your quadratic graph, if I have a graph and I have two x-intercepts, one at 3 and one at 5, and I got those just from this factor, that means that our parabola will look something like that. And since this is an inequality, we're going to shade one side of this line or the other, or the inside of this parabola or the outside of this parabola. So that means that these x-intercepts represent x values where our solutions start and end. So if I have the solution x is equal to 3 and x is equal to 5, when y is equal to 0, that means on this number line I can draw an open circle at 3 and 5. Now it's an open circle because this is a less than sign. Well, since I have those key points, now I can just test points in these three different regions: to the left of 3, between 3 and 5, and to the right of 5. So to do that, I'm going to test to the left of 3 first, and I'm just going to plug in any one of these numbers. I'm going to choose 0, and we're going to plug that in for x. And remember, this is when y is equal to 0. So we'll have 0 is less than 0 minus 3 times 0 minus 5. So this is 0 is less than negative 3 times negative 5, where 0 needs to be less than 15, which 0 is less than 15. So that means all the points to the left of 3 are solutions. So you would color in everything to the left of 3 on the number line, like so. Now we would test a point in the region between 3 and 5, so we plug in 4. And if we do that, remember y has got to be equal to 0. So we'd have 0 is less than 4 minus 3 times 4 minus 5. You could also plug these into our original equation if you'd like. This would be a 1 and a negative 1. So we'd have negative 1 needs to be greater than 0. But it's not. So the region, since 4 doesn't work, the region between 3 and 5 are not solutions to this inequality. Then our last step is to test something to the right of 5. So I'm going to choose 6. If we plug in 6, we get 0 is less than 6 minus 3 times 6 minus 5. 6 minus 3 is 3. 6 minus 5 is 1. So we have 3 and 0, or 0 is less than 3. And that is true, so that means everything to the right of 5 is also a solution. So again, you color that in like so. Now looking at this number line, we can see the solutions of x for this inequality. Our solutions are x is less than 3, because that's all these points that are less than 3, and x is greater than 5, because that's all the points greater than 5. So our solutions then for this inequality would be x is less than 3 and x is greater than 5. Let's try this again. Here we have y is less than or equal to x squared plus 9x plus 20. Well, once again, I can factor this. This is x plus 4 and x plus 5. This also means that I have the x-intercepts of x is equal to negative 4 and x is equal to negative 5. Now this is a less than or equal to sign. So I'm going to put points at negative 4 and negative 5, but I'm going to put solid points because these points are valid solutions. Now we need to test points in these three different regions: less than 5, greater than negative 4, or between negative 5 and negative 4. First I'm going to do to the left of negative 5. So I'm going to plug in negative 6. And I'll plug it into the original equation this time. So we'll have y, which is 0 right now, is less than or equal to negative 6 squared plus 9 times negative 6 plus 20. Negative 6 squared is 36. Negative 6 times 9 is negative 54, and then plus 20. This is equal to 2. So we have 0 is less than or equal to 2. Well, 0 is less than or equal to 2. So that means everything to the left of negative 5 is a solution. So again, we'd color that in. Next, we test the point between negative 5 and 4. So we'll pick negative 4.5. If we plug that in, we'll have 0 needs to be less than or equal to negative 4.5 squared plus 9 times negative 4.5 plus 20. Negative 4.5 squared is 20.25. 9 times negative 4.5 is negative 40.5. And then plus 20. If we add these all together, we're going to get this is equal to negative 0.25. So is 0 less than or equal to negative 0.25? And the answer is no. The negative is less than 0, not greater. So that means the points between negative 5 and 4 are not solutions. So lastly, we have to check numbers to the right of negative 4. So I'm going to pick 0 because it's usually easy to solve. If I plug in 0 for x, we'll have 0 is less than or equal to 0 squared plus 9 times 0 plus 20. 0 squared is 0. 9 times 0 is 0. So we have 0 is less than or equal to 20. Which it is. That works. So that means all the points to the right of negative 4 are also solutions for this inequality. So we color those in again, and our number line would look something like that. So looking at this number line, we can see the solutions of this inequality. We have x needs to be less than negative 5, or x needs to be greater than negative 4. Now look closely at these negative 5 and 4. We put solid points there. This is a less than or equal to sign. So this is actually x is less than or equal to negative 5, and x is greater than or equal to negative 4. And those would be our solutions. And that completes the tutorial on quadratic inequalities.